Ever wondered why a car's speedometer shows both speed and distance? Or why a pendulum swings back and forth in a regular pattern? Welcome to a fascinating exploration of the world of motion and measurement. Firstly, let's delve into the concepts of rest and motion. If you're sitting in a chair listening to this, you might think you're at rest. But from the perspective of an astronaut looking down from space, you're moving as the Earth rotates. This highlights the importance of a frame of reference, a point from which we observe and measure motion. Now consider the variety of ways objects move. A car driving in a straight line demonstrates rectilinear motion, while a merry-go-round exhibits circular motion. And that pendulum mentioned earlier? It shows periodic motion, swinging back and forth in a regular, repeating pattern. Accurately measuring these different types of motion requires understanding units of distance. When you measure the length of a room, you might use meters. If you're calculating the distance between cities, kilometers come in handy. And for tiny things like the thickness of a hair, we use centimeters. Time is another crucial factor in motion measurement. The standard unit of time we use is the second. With distance and time, we can calculate speed, which is simply distance divided by time. But what if we want to know more than just how fast something is moving? That's where velocity comes in. Velocity tells us the speed and direction of an object's motion. These concepts of speed and velocity allow us to distinguish between uniform and non-uniform motion. Uniform motion is when an object covers equal distances in equal intervals of time, like a car moving at a steady speed. Non-uniform motion, on the other hand, involves varying rates of motion, like a roller coaster speeding up and slowing down. To visualize motion, we use distance-time graphs. These graphs provide a clear picture of how an object's motion changes over time. So, to sum up, we've looked at the concepts of rest and motion, frames of reference, different types of motion, units of distance and time, speed and velocity, uniform and non-uniform motion, and distance-time graphs. Each of these tools allows us to understand and quantify motion with precision, helping us make sense of the world around us. Remember, the next time you see a speedometer, a swinging pendulum, or a roller coaster in action, there's a wealth of knowledge and understanding behind each motion. And that's the beauty of studying motion and measurement.